Hi everyone watching live at the Microsoft Silicon Valley campus and watching virtually as well. The single biggest change in the shopping experience in recent years is the digitization of commerce. Brands and retailers have gone from fighting over limited shelf space in physical stores to fighting over the infinite shelf space across the internet. Standing out amongst the crowd is now harder than ever. One advantage e-commerce companies possess is the scale of data they have and collect. Creating impactful insights using AI can be the differentiator between winning and losing. Today we're going to explore how to tackle big data problems with lightweight solutions with the help of ONNX. Before we get into that, a little bit about myself. I've been fortunate enough to work with a range of innovative tech for several years now. I'm currently a software engineer at Bazaarvoice, and over the past year or so, I've been focused on harnessing AI to improve the online shopping experience by delivering e-commerce machine learning solutions to the cloud. So let me try to illustrate the scale of data in e-commerce and why the application of AI is so compelling by using Bazaarvoice as an example. Bazaarvoice manage and process data for over 1 billion shoppers a month. They have the world's largest network of brands and retailers, and they provide over 8 billion total reviews for these brands and retailers. The variety and data and scale of data here would cause any data scientist's mouth to water. It's obvious there's massive opportunity here to innovate in this sector using AI. It's the reviews I want to focus on today specifically. The Bazaarvoice network allows brands and retailers to share product reviews across catalogs, meaning one review on one site can be shared to every place that product is sold online. More reviews equals more consumer trust, which ultimately equals more sales. The process of sharing reviews is called review syndication, but this is a topic for another day. We want to explore the concept of sharing reviews today, and that concept is powered by product matching. Product matching is the process of determining if two products are the same. It's the core function of the machine learning model we built. Product matching is performed by comparing unique product identifiers, but whatever is left over and can't be unmatched is done manually, or in other words, by humans. In fact, over 1 million product matches a month are performed manually. You can imagine how tedious this can get and expensive as well. But how do humans product match if we take a step back? Well, if we take a look at these two products on screen now, how can we tell they're both the same? Well, we look at the picture, we read the text, price, ratings, reviews, the description, and gather enough data to come to an accurate conclusion. And subconsciously, we're carrying out techniques that machines use to solve this problem: numerical processing, text processing, and image recognition. And these are the basis of how we built our model. And of course, we need data. We gathered a data set of over 3 million historical product matching human decisions to train our model to a 99% precision rate. So that's the first part of our solution, the model. A sci-kit learn model built with Python, exported to ONNX format. Now that's all well and good, but how do we implement this into our services to generate real business value? Well, let's now look at approaches to deploying machine learning solutions to the cloud. For me, the ideal solution is an implementation that is the most lightweight, cost-efficient solution that also maintains performance. With that in mind, these points here on this slide are based on results I've personally seen in the past. On the y-axis is complexity, on the x-axis is cost from high to low. First of all, we started looking at virtual servers like Azure Virtual Machine or AWS EC2s. This can give you the most flexibility as you have an actual OS to work from, but comes with some unnecessary configuration and costs, especially if you're using it specifically for machine learning. I'll touch a bit on costs later, but why overcomplicate things when we don't have to? The next consideration is a cloud ML platform like Azure Machine Learning or AWS SageMaker. We now have the benefit of dedicated ML tools at a lower cost in some cases than a virtual machine. But we must remember at this stage, it may be the case that the machine learning engineer hands over the model to an engineering team to implement. And personally, I want a development pipeline that software engineers who don't specialize in machine learning can pick up and use seamlessly. So that's when we arrived at our third option, serverless functions. Now, like Azure Cloud Functions or AWS Lambdas, these remove the overhead of managing servers, configuring software, and patching operating systems. And they're also very cheap. So this is the option we explored. And this is a solution we came up with. So we developed a sci-kit learn model, exported it to ONNX format, and built it with Python, deployed it to a serverless function, and we used a node environment to run inference on ONNX Runtime. ONNX gave us the flexibility to be able to build a model in Python and deploy it to whatever environment we wanted. We chose Node because that was based on similar approaches we've chosen in the past, so it really worked well for us. And by running this, we can send predictions out to our network. And just by using this lightweight solution, we were able to process hundreds of millions of pending product matches within the timeout limits and deployment size limits that are part and parcel of serverless functions. What's also great about this solution is the modularity of it. We can plug this in anywhere to any of our services quickly and easily. But how do we scale this solution to hundreds of millions of predictions? Well, if we look at this table, this is based on results I've seen in the past with machine learning inference on serverless functions using ONNX Runtime. These metrics help us find the optimum memory size to avoid timeouts and ensure the best performance while keeping costs low. I like to use the metrics memory used and execution time. If the memory used nears the total allocated memory or the execution time nears the timeout limit, we know we need to scale higher. This is an instant indication that we need to scale. If we look down the left at allocated memory, we can see that at 4 gigabytes, performance plateaus. And therefore, 2 gigabytes is the ideal memory size for us as it stays within the memory usage and easily within the timeout limits, and is also the lowest cost there at $2,800. Now, if we compare this same model with the same compute loads across serverless functions, cloud ML platforms, and virtual servers, we can get a great grasp of the cost savings here. You can see that serverless functions is significantly cheaper in our case than the cloud ML platform, and significantly again cheaper than a virtual server. So there's great cost saving potentials here by using this lightweight approach. One consideration I'd like to bring up is that Python packages add up very quickly. We can see by this chart that the orange and blue line donate deployment size limits of serverless functions, and that popular machine learning frameworks like TensorFlow and PyTorch already exceed these limits. And that's even before we add any logic to our serverless function. ONNX helps us reduce the size of our models during deployment, but sometimes our deployment sizes are too big. There also are workarounds around this, like fetching our model from a different cloud storage source into our serverless function. But again, ONNX helps us reduce the size of these deployments. So the two main considerations to these approaches is the deployment size limits and working within the timeout limits. But I hope this demonstrates the power of ONNX and ONNX Runtime when deployed to a serverless function. Using this lightweight approach, we are able to match hundreds of millions of products across thousands of client catalogs at high speeds, resulting in over 15 million extra reviews for brands and retailers, proving that this approach is fit to process data on a grand scale. So we've explored just one way of utilizing the capabilities of ONNX and ONNX Runtime. If you want to hear more or want to share your use case with me, please reach out. I'd love to hear it. And as someone actively working in this space, I'm both intrigued and compelled by where these technologies are taking us. Thank you.